Okay, hi there, Dr. Matthew J. Trom here. Welcome to a new module in the EML 4501 course. So we are starting the Creative Ideation module, and I'm going to spend this asynchronous lecture describing to you something called the function analysis method for divergent thinking. Um, to give us kind of a grounding, a sense of where we are in the design process. You guys have seen this from me before. Remember our total University of Florida mechanical engineering capstone design process is a 20-step process, right? So here we are in all 20 steps. And the green line represents the separation between 4502 and 4501. 4501 being Mech 2, our class, and 4502 being Mech 3, which is the follow on build realization class. So we're up here in 4501 on the top. And in starting the creative ideation section, we have walked through identifying the problem, researching the problem, and quantifying metrics to get into concept generation. And so this method is an alternative technique for concept generation. You guys know concept generation probably from DML or from some of your other classes or sort of independent creative activities. And the one that you probably know is brainstorming, right? That's you make just a list of ideas and you try to be as divergent as possible as you're generating those lists. And that's fine. That's a good technique. But the intent here is to give you guys a different technique to come up with some more new, different concepts if you've completely exhausted anything that you can come up with from just brainstorming. So this is yet another divergent thinking kind of creative concept generation technique to help you guys with your concept design reports. Most importantly, the concept generation phase of that report. So and here's why we do this is because divergent thinking is essential to design. So you guys are training as engineers. Scientists, in a way, fall into the same boat in that scientists and engineers are essentially trained to solve problems by thinking convergently, right? So think about like every problem that you've ever solved in any sort of science or engineering class before you got into 4501. And what did you do? Well, you found the simplest, most direct path to the solution. You reduce the complexity of the problem whenever possible to keep things simple. And once you got to the final answer, you had closed-ended solution. One true answer. You flipped to the back of the book, agreed that the answer that you calculated is the one that corresponds to the answers in the back of the book. And hallelujah, you're done. That's the end of the design, or that's the end of the problem solving process, right? All very kind of convergent on a single solution. So one of the things that makes design really difficult, especially for scientists and engineers, people have been training their entire lives to solve problems as efficiently as possible. Is you need to explore the entire design space, and exploring the entire design space requires divergent thinking to identify solutions that might not be initially apparent or obvious as you start to tackle a design problem from the beginning. And in divergent thinking, we go against everything that you've been trained to do to solve a problem as an engineering student, in that we start by making the problems more complex, generate a lot of concepts, right? So instead of going towards one solution, we go away from one solution to generate a lot of different possible solutions. And the goal of doing that is to expose or explore the entire design space, because if you have a customer needs statement and you all of a sudden just gravitate to one solution, the first solution that pops into your mind, your design space is limited by kind of your initial thinking, and better solutions than the one that you've come up with might initially be hidden from view. And so we need divergent thinking techniques like the functional analysis method to reveal the entire design space and to get us out of this sort of convergent thinking mode that we've been in, basically for entire careers all the way through pre-K, kindergarten, elementary school, middle school, high school, and college. Right, you've been trained to think this way. So we gotta break you of 20 some odd years of thinking convergently when you're doing design, which requires again divergent thinking. Okay, so the way to sort of get acclimated to this approach to divergent thinking and creative ideation that is not brainstorming is to think about functional levels. And every design problem can be kind of addressed at many different levels of detail. So one example that I would use is if you think about communicating with people in the modern world. We all use cell phones now, but that communication problem has many different levels to it, right? So the level of the cell phone, the single handset, there's a set of problems that are associated with the usability and the interface and the power and the information collection and dissemination that go into a cell phone. So that's sort of one level of detail, but then you might then think about not just a cell phone manufacturer, but an entire cell phone company, right? So AT&T, for example, or Sprint. They have an entire telecommunication system that they have to manage, and that includes, your little headset, but then also the cell phone towers and the employees and the infrastructure and the satellites and the billing system and everything else that goes into having a fully functional telecommunication system. So we got to be cognizant of the level of the problem before we can start to apply this method. The other example that I want to give that I'm going to spend a little bit more time on is to talk about doorknobs, right? So egress from a door is achievable if you have a door without a doorknob, right? And I'm probably dating myself here a little bit, but this is an image from the movie Home Alone, which is starring a baby version of Macaulay Culkin. This is not Macaulay Culkin. This is one of the villains in the movie, and they were able to get into a house where Macaulay Culkin, who was like 10 years old, was basically there home alone for several days because his parents went on vacation and accidentally left him there. And he had to defend his house from these villains who were trying to rob his house. And one of the ways that they tried to get into the house was not by breaking through a door, but just by crawling through the dog door, right? So that's one way that you could conceivably open a door, by just creating a panel in the door and moving through the panel. Another way to open the door without a doorknob is to have something like a latch, right? So this is maybe the way that you would open and close a barn door or something where you don't want to grasp and turn a doorknob. So these divergent ideas are potentially beneficial when you're doing the creative ideation process. The challenge, though, is if you think back to the entire engineering design process, right here is customer likes ideas, right? And as you go from concept generation to eliminating impossible concepts to the concept design review, the concept design review gives the customer the chance to say, no, I don't like your ideas, and I'm going to kick you back to concept generation. And so you need to be cognizant again of how far outside of that box you're going. It would be disastrous if your client was a doorknob manufacturer and you came to them with a number of door egress solutions that did not involve doorknobs, right? You're basically describing ways that you're going to put them out of business. So that's sort of the preview. Now, there are instances that exist where a change of focus is essential to widen the overall design focus. That is, to improve the creative ideation using something other than brainstorming that you're so familiar with. So it's useful to have a means of considering the level of the problem. So with this technique, we do not consider types of solutions. Instead, we consider just essential functions that satisfy customer needs. And this is quite helpful because you guys now have a customer needs statement. And the very first thing that you're going to do in the concept design report is to try to take all of those customer needs and assign them to subsystems or functions that eventually are going to become your down selection matrices. And so this technique aligns really nicely with the thought processes that you guys are already doing anyway at the beginning of your concept design report. So the way that the function analysis method works is it concentrates on what must be achieved, and our goal is to establish a boundary around a subset of functions. So this is effectively your subsystem. And you're going to represent your subsystem, or in this case, we call it your product, to be designed as a black box. And the reason that this method is so near and dear to my heart, of all the different sort of divergent thinking, creative ideation methods that I could have talked about, this one I think is really cool because it parallels really nicely what we do in the energy thermal fluid sciences with respect to putting a control volume around a system as a system boundary, and then looking at flows of mass, momentum, energy, etc., into and out of that system boundary. So this is very analogous to that. And you guys know I'm an energy thermal fluid science guy, right? So I love design approaches that mimic energy thermal fluids type analyses, and this one is the hallmark of all of them. Okay, so what does this black box do? Well, it represents basically the product or the subsystem that you're trying to think about, and the box converts all of the inputs to outputs, right? So the energy input, material input, and information input all get converted into energy output, material output, and information output. The box also contains all the functions needed to convert the inputs into the outputs, and I'll describe in a second like what the inside of the box looks like, but right now we're just talking about like the outside of the box. And then finally, the box represents a boundary that defines the product or the subsystem in this case from its surroundings, right? So you guys in your creative concept design report are going to have to come up with subsystems or functions that are kind of like subcomponents of the overall system design. And again, that's another reason that I like this technique, is it has parallels both in the energy thermal fluids and also in how to start thinking about the breaking down of the overall system into subsystems that then have concepts assigned to them that are then down selected and selected for prototyping. So this is very, very similar to that in terms of kind of the deconstruction of the overall system that you have to do. Okay, and so it's beneficial to classify flows of materials, energy, and information into and out of the box using different line types. So I use different colors, red for energy, green for materials, and purple for information. Okay. So here's kind of an overview of what we do for this method. So in the box are sub-functions that convert the inputs to the outputs. Each one of those sub-functions is expressed with a descriptive combination of a verb or a noun. So they, for example, remove waste or amplify a signal, right? So remove is the verb, waste is the noun, amplify is the verb, signal is the noun, right? So this noun-verb combination describes each one of these sub-functions that live inside the box that are converting the inputs to the outputs. Now, like a block diagram in controls, for example, each of those sub-functions has its own inputs and outputs. So you don't just kind of run energy through the box and not have it connect to anything and just out the other side of the box. There actually will be connections inside the box between the inputs, the subsystems, and the outputs, or the subfunctions and the outputs. And they are linked using a block diagram technique to chart the flows of energy, materials, and information through the system. A so-called correct black box is one that contains all necessary subfunctions and shows how their inputs and outputs are linked together, right? So this could be, if done well, kind of encapsulated and put forward to the customer as a potential initial concept that you would give them in the concept design review. Okay. So I'm right at 15 minutes. You guys know I like to stop at 15 minutes and give you a break to go to the restroom. Just take 5 minutes to zone out, whatever you want to do, and then come back. So I will stop there, and we will see you in the follow-up video to describe an example of using the function analysis method for creative ideation. Okay, see you in a sec.